In this class, now I am going to explain you G Advanced 2023 paper 2 question. This is a connective based question. This connectivity is there between the matrices and permutations and combinations. Now see that question. One matrix R given as set builder form like this: A3B C2D 050, where A, B, C, D belongs to this 8 elements. Okay, then how many invertible matrices can be generated from this set? Matrix is given in set builder form. How many invertible matrices can be generated from this data? Because here A, B, C, D, some alphabets they kept. We have to replace those alphabets by these numericals. By replacing A, B, C, D by these numericals, how many invertible matrices can be generated? This is the question. Now let us answer to this question. See students, you know the meaning of invertible matrix, which means that inverse of the matrix should be possible. For which type of matrices inverse is possible? See, observe that it is a 3 by 3 matrix, square matrix. If whose determinant is not equal to 0, then that is called a non-singular matrices. For non-singular matrices only, we can able to find inverse, because inverse of the matrix formula you know, A inverse is equal to 1 by dta into adjoint of A. So here whichever is placed here, that should not be equal to 0. If it is 0, meaningless, not defined case will come. Hence, so to make it possible, so dta should not be equal to 0. So here also, to get the invertible matrix, here determinant R should not be equal to 0. Yes. Now find determinant of this matrix R. You know how to expand it. A into, leave the row and column. So here minus 5D you will get. Now go to the second element, minus 3. Leave the row and column. So 0 you will get. Go to the last element, B. Leave the row and column. 5C. This should not be equal to 0. Now take 5 common from all of them. So here it is going to be BC. Here it is minus AD. Should not be equal to 0. Send 5 to the right side. So BC minus AD should not be equal to 0. You have to assign A, B, C, D values here from this set such that BC should not be equal to AD. If BC is equal to AD, then this det will be 0. If it is 0, inverse will not be existed. Hence, so identify the possibilities for A, B, C, D such that BC should not be equal to AD. Shall I identify? Now let me explain you. Okay. First I would like to find BC and AD. No. See, there are 4 places which have to be filled by. Here how many are there? Count all of them. 8 elements are there. Now fill these 4 blanks. By that 8 elements, how many such choices are there? To fill the first blank, how many choices do I have? 8 choices. Go to the second one. To fill the second blank, how many choices do we have? 8 choices. For the third one also 8. So 8 power 4. Now multiply this. 8 power 4, I think 4096 you will get. 4096 ways you can fill these 4 blanks. How many ways can we assign these 8 elements to these 4 blanks? This many ways. But among all that possibilities, in some possibilities you may get BC equal to AD. If BC equal to AD, then det becomes 0. So hence inverse will not be possible. Even such type of possibilities also contained in this 4096. How many such kind of possibilities. Identify them after getting all of them. So which have to be subtracted from 4096 to get correct answer for this question. Now observe me how I am going to identify such that BC equal to AD. So in the case 1, BC, AD, both should not be equal, but when these two are equal, identify in the case 1. Okay students, so here if all the elements are equal, then the left side part or right side part both are equal kada? See here. Okay students, take 0. Now assign 0 for this place, this place, this place, this place. That is one choice. And okay, if I write here 3, 3, 3, 3, 3, 3 is 9, 3, 3 is 9. Repetition is allowed here. So you can give A equal to 3, D equal to 3. And B equal to 3, C equal to 3 also. Yeah, repetition is allowed. So you can place all of them by 0, all of them by 3, all of them by 5, all of them by 7. Even though you will get left side, right side equal, no? Hence, how many such possibilities will come? 8 choices. So these we don't want. Go to the second case. In the second case, this is BC, this is AD. Any one of BC, any one of AD is 0. Where do you want to put 0? Either here or here. Two choices. You can keep 0 either in BC. You have to keep either B0 or C0. Any one of these two is 0. So how many such possibilities there? 2. Either B can be 0 or C can be 0. Two choices. If I feel this is 0, to fill this place, there are remaining 7 elements. Otherwise, if I write 0, here 7 possibilities. So that select the place for 0. That is done by 2C1 and the rest of the place is filled by 7 choices. Here also. Select the place for 0. 2C1 and 7. So, are you getting me students? In the case 2, any one of this left side, any one of right side is 0. Okay, even though result is 0 equal to 0, equal no? So such kind of possibilities we don't want, which have to be subtracted from 4096. How many such possibilities are there means you have to take the product of all this. You know the multiplication rule of permutations. Okay students. So I have written here all these possibilities. Now take the product of all this. 2 7s are 14. Here 2 7s are 14. 14 14s are 196 such okay possibilities will come, which we don't want. Okay. Now okay, here I am writing here 8. Shall I write here 8 plus 196. Next go to the third case. In the third case, among that 4, BC, AD, any 3 I would like to keep 0. Any 3. Here I kept 3 places 0. In one place I want to put non-zero. Like if I keep here 7, 7 is there. Then how many ways can you arrange this? You know, permutations with constant repetitions are allowed. There are 4 places. Now permutate these 4 places by 4 elements, 4 factorial ways. But among that 4, 3 are repeating, 3 factorial. Okay students? But here, why do we fill only 7? You can fill remaining any one of the 7, 6 no? Total 8 are there, 1 is 0. Here I kept 7. Okay, so however we kept here 7, in the same manner you can put a non-zero element here. How many such possibilities are there means 7. Because among this 8, 1 is 0, remaining 7 are non-zero elements. You can fill any one of the non-zero here. Not only 7, but also you can fill any non-zero element. So such possibilities are 7. So 4 factorial by 3 factorial 7 and 4 7s are 28. So here write 28. Okay students, I hope you have got it. Now go to the fourth case. In the fourth case, don't get any confusion. I would like to put non-zero elements for BC and AD such that both are equal. Okay, in the previous case, I think you might have understood. Among that BC, AD, if any three are 0, here BC, A, 0 means this result is 0, this result is 0, both are equal. Otherwise, if you put these three 0, this should be non-zero. So left side, right side, you will get zeros. Hence, okay, I took that condition. Any three of them are 0 and one is non-zero. So such possibilities 28 you got, which we don't want. Because at those possibilities, you will get, okay, singular matrix. Hence inverse will not be existed. So now this is the last case in which don't take 0 here. You have to assign A, B, C, D as non-zero elements. For B, C, A, D, which type of elements I am going to give? Non-zero elements. Suppose if I write here 3, here I can keep 11. I took 2 elements from this, here I wrote 3, 11. Otherwise I can write 11, 3. Here also 3, 11 or 11, 3. Okay students, from that 7, you have to select 2 elements, 7C2. From that 11, I took 2 elements. Which 2 elements do I take here? 3, 11 I took na? Like that. 7 elements are there with us, we want 2. That is done by 7C2. And again here, the 2 elements you can write 3 into 2 or 11 into 3. Means the 2 elements you have to permutate here. That possibilities is 2 factorial. Like 3, 1, 3, 11, 11, 3. 2 choices na? 2 factorial means 2. Here also. So here 7C2 into see students, already selection is done. So here just permutate it, 2 factorial. From that 7 we have selected 2 elements. Which 2 elements do you select means 7C2. Again you have to permutate in this place, in this place. This is done by 2 factorial, this is done by 2 factorial. Here it is 4. Now simplify. 7 into 6 by 2 into 1, 4. 2, 1. See students, see here how many have we got here? 7 3 is 21, 21 4 is 84, 21 4 is 84. Now this collection we don't want. Now add all of them. So if you add all of them, how much do you get? 8, 196, 28, 84. Now 8 4, 12. 12 6, 18. 18 8, 26. Okay students. Correct only now? 12, 18, 26. 10, 12, 12 plus 9, 21. 316. So these possibilities must be subtracted from this. 4096 minus 316. 0, 8, now 7, 3. So this many matrix can be generated from this set R, so which are invertible. Thank you students. I hope you have understood. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you and all.